Hello students, welcome to Physics Pathshala. Today we'll discuss in detail Physics Class 11 Part 1 chapters. In this Class 11 Part 1 we'll be covering motion of objects. In addition to that, unit and measurement and physical world. Under motion, it will be of three types. One will be linear motion, another is rotational motion, and third one will be gravitational motion. Again, linear motion will be of two types. It will be one-dimensional or motion in straight line, two-dimensional or motion in plane. This one-dimensional motion in straight line will be of horizontal motion or of vertical motion. Two-dimensional or motion in plane will be of horizontal motion or of also vertical motion. One-dimensional or motion in straight line, horizontal motion will cover. It will have scalar motion or vector motion. Under scalar motion, we will be studying distance and speed. Under vector motion, we will be studying displacement, velocity, and acceleration. Under vertical motion, we will have motion under gravity. This it will be only vector motion. This will be of two types, either upward motion or downward motion. Under two-dimensional or motion in plane, will have motion, horizontal motion or vertical motion. Horizontal motion indicates motion of the object parallel to ground. Vertical motion indicates motion perpendicular to ground. Horizontal motion will cover uniform circular motion, whereas vertical motion will cover projectile motion. Projectile motion will be of two types. One will be oblique projectile and another will be horizontal projectile. Then the next type of motion is rotational motion, and third one is gravitational motion. Capitalizing, we can say complete physics will cover class 11 part 1 and class 11 part 2, class 12 part 1, class 12 part 2. Under part class 11 part 1 will be covering motion of the objects. In addition to that, we'll be studying unit and measurement and physical world. Motion is the change of position of an object. If any object is not changing its position, it will be termed as it is at rest. If it is changing its position, it will be termed as it is in motion. It may move parallel to ground or it may move perpendicular to ground. When one dimension or one coordinate changes during the motion, it is termed as one dimensional motion. When two coordinates changes at each point of motion, it will be termed as two-dimensional motion. Coordinate indicates the position of the object. In one-dimensional motion, coordinate is chosen either x axis or y axis, and axis is chosen along the direction of the motion. Whereas in two-dimensional motion, two axes are chosen. One will be x-axis and another will be y-axis. One will have origin, the reference point. Position of an object will be indicated by two coordinates x and y. If position of the object at p1 coordinate delete x1 y1, and after some time it has reached to some position p2 coordinate becomes x2 and y2, it says at initial position object was at x1 distance from origin along x-axis and at a distance of y1 distance along y-axis from origin. During motion, it has moved to another position. At that second position, its coordinate became x2 and y2. That indicates it has changed its location along x-axis also, and it became reached to a point x2 which is x2 distance from the origin, and y2 distance from origin along y-axis. Now it has changed both its coordinates. It became x1 to x2, and y coordinate, y changes from y1 to y2. As both two coordinates are changing during the motion of the object, it is termed as two-dimensional motion. Now, once we go to one-dimensional motion, object may move parallel to ground, then it is termed as horizontal motion. Horizontal motion can have a scalar nature motion and vector nature motion. Scalar motion indicates the only numerical value of the motion, how much distance it has, how much path it has covered, and at which rate it's covering the path. It does not indicate the direction in which direction object is moving. The length of the path it is covered is termed as distance, and the rate of change of position or distance covered per time is termed as speed. When direction is mentioned in which direction object is moving, then this distance changes to a new term that will be termed as displacement. Displacement indicates change in position in a particular direction, and it is measured by final position minus initial position. Whereas the distance is always the total path length, actual path length. Now, speed is the distance by time, and velocity indicates the rate of change of position, which is equal to displacement by time. When velocity changes, the rate of change of velocity or velocity per time, change in velocity per time is acceleration v1 minus v2. The change in velocity, initial velocity or you can say v2 minus v1, initial velocity is v1 and final velocity v2. Change in velocity is v2 minus v1, time taken is some t, then acceleration is change in velocity by time taken. Now, if object is moving upward, it is termed as motion under gravity. Here the acceleration is acceleration due to gravity, and if it is moving upward, it is upward motion, and if it is coming down to ground, then it is downward motion. Here only direction of the object only changes. While going upward, it will be upward motion, and while coming down, it will be downward motion. During this vector motion, we will have three terms: displacement, velocity, acceleration, and along this we will be studying kinematics. Kinematics is study of an object in motion without considering or including the cause. Cause is the external force that makes the motion. Hence, excluding force, we will have these three terms. If final velocity is v, initial velocity u, change in velocity is v minus u. Rate of change in velocity is v minus u by t if t is the total time taken. Then this term rate of change of velocity is a, that is acceleration. V is final velocity, u is initial velocity, and during this time t, the displacement is s, or distance covered along that direction is s. Then a becomes v minus u by t. From these we get three equations. One becomes v is equal to u plus at, and another one is v square is equal to u square plus 2s, and third is s is equal to ut plus half at square. These three equations will be valid for motion under gravity, whereas during upward motion, if we take a is minus g, and during downward motion it will be a is equal to plus g. Rest all will remain same, and this kinematic equation will become, for upward motion it will be v is equal to u minus gt, and whereas for downward motion it will be v is equal to u plus gt. Here this acceleration is acceleration due to gravity, and if it is thrown upward with certain velocity, initial velocity u, and velocity keeps on changing, and finally it reaches at certain height where velocity becomes zero. That is the maximum height it reaches. That indicates that maximum height v becomes 0. In that case, the t becomes u by g. After attaining velocity 0, it changes its direction and comes to down. Now, summarizing what you have studied till now, I have studied in physics. We will be covering the chapters that can be grouped into two categories. That one will be studied in class 11, and another one will be studied in class 12. In class 11 again, we can categorize all the chapters into two parts, part 1 and part 2. Same way, class 12 chapters will be categorized into part 1 and part 2. Under part 1, class 11 chapters will be focusing on motion of objects. Under part 2, Class 11 will be focusing on properties of matter. This motion again will be of three types. One will be linear motion, another will be rotational motion, and third one will be gravitational motion. This linear motion again will be of two types. It may be of one dimensional or another will be two dimensional. If it is one dimensional, it will be termed as motion in straight line, and two dimensional motion, it will be termed as motion in plane. Motion in straight line will have either scalar motion or vector motion. The scalar motion will be studying distance and speed. Speed can be of uniform speed or variable speed. For variable speed will be calculating average speed and instantaneous speed. Whereas vector motion will cover three terms. One will be displacement, another is velocity, and third one is acceleration. With this, we'll be studying kinematic equations. We'll have three equations: one v, v square, and s. First equation is v is equal to u plus at. Another equation is v square is equal to u square plus 2s, and third one is s is equal to ut plus half at square. This kinematic equation will be valid in all cases of motion. Now, once we go to two-dimensional motion, it indicates during the motion two coordinate of the object changes. Whereas in one dimension, one coordinate of the object changes, and in this one coordinate we use only one axis, and that axis is along the motion of the object. One axis. Here two axes are used, and two coordinates are always used to indicate the position of the objects. If it changes its position, then both the coordinates changes. In this, it is termed as motion in plane. Motion in plane can have of horizontal motion and vertical motion. Under this 1D or motion in straight line, under vector motion will either horizontal motion or vertical motion. Horizontal motion is the motion parallel to ground. That is motion of an object parallel to surface of the earth, whereas vertical motion indicates perpendicular to ground or perpendicular to surface of the earth motion. That means in which motion of the object is perpendicular to ground, or object is moving perpendicular to ground. It can have of two types. Either it can move upward from ground, or it can come from top any position towards ground. Then it is downward motion. Then we'll have rotational motion, that is motion of an object around the axis, around certain axis. And each part of the object makes an angular motion. Rotational motion is your angular motion. That means it makes an angle at axis or the center if it is chosen on axis. Gravitational motion is the motion of gravitational force is acted upon it. Motion of planets. As Earth is one of the planet and Earth is involved, Earth and other objects are Earth and satellites. Under this we will be studying what is the acceleration due to gravity due to Earth, g, and what is the escape velocity of satellite and what is the orbital velocity of the satellite. And this g changes along height, along depth, and along latitude. Latitude is due to the rotation of the earth. If we go away from surface, then height increases and this g changes. This g has come from the law of universal gravitational force. Law of gravitational force says if two objects having different masses or having certain masses attract each other with certain force, that force is directional to m1 m2 multiplication of masses and inversely proportional to square of the distance between them, then it becomes f is equal to certain quantity, fixed quantity, this g, times m1 m2 by r square. G is gravitational constant and it has a fixed numeric value. Along with this, we'll be studying what is physical world and unit and measurement. Under properties of matter, we'll be studying mechanical properties and thermal properties. The mechanical properties will be studying mechanical properties of solid and mechanical properties of liquid. Under thermal properties, we will be studying thermal properties of matter, thermodynamics and kinetic theory of gases. Another one will be studying oscillatory properties. Under this we will be studying oscillation and wave. Now, when we say we'll be studying physical world, we'll be covering what is physics and role of physics. Then what are the fundamental forces coming in effect in nature, and another will be what is energy and law of conservation of energy. Different forms of energy and law of conservation of energy. Under this, what is physics and role of physics. Physics is, under what is physics? Answer is, it is study of nature and natural phenomena. It is branch of science. It is one branch of science in which we study nature and natural happenings or activities going on in nature. Science is study of any subject with a scientific method. What is this scientific method? Scientific method involves three major steps. One is continuous or systematic observation. then experimenting. That experiment is controlled experiment. And finally, from this experiment we come to certain conclusion with getting the mathematical formula or mathematical modeling. After getting this mathematical formula, we become able to predict the outcome in different occasions. This continuous systematic observation or this exploring of nature, exploring of nature, that is systematic observation. Then what we have observed, we do certain experiments to find out what will be the outcome in different conditions. That becomes our predict. Now, with the science, and when we study nature and natural phenomena, it becomes physics. Under this physics, we will be studying nature. Nature, as we know, consists of big or macroscopic particles or very small microscopic particles. Study of these macroscopic or terrestrial and celestial objects, terrestrial or celestial objects, that's which is visible to our naked eyes, is termed as macroscopic particles or objects. A study of these macroscopic particles or objects, we say, categorize as classical physics. Whereas study of microscopic particles will be studying under quantum physics. This classical physics will cover or can be categorized into 4 categories. One will be mechanics. Mechanics will deal with motion of objects. Another one will be electrodynamics, that will deal with electric charges. Third one is thermodynamics, that will deal with heat flow. And fourth one is optics, that will deal with light. And quantum physics will deal with study of atom, nucleus and molecules. Once there will be flowing heat, effects will be changed in internal energy, temperature, etc. When body will change its position, body or particles, then it will be termed as motion, and that will be studied under mechanics. Optics will deal with light, certain laws and optical instruments. Under this physical world, we have another two terms. Next one is fundamental forces that will come across during our day-to life. One will be gravitational force, another one is electromagnetic force, and third one is nuclear force of strong nature, and fourth is nuclear force of weak nature. This strong nuclear force is the strongest force among all these fundamental forces. This gravitational force comes into existence when there is a there are objects having masses. It is always attractive. No medium is required. If two objects are kept at certain distance and in between them no medium is there, still also the force will come into existence. Example, this earth and certain other objects. Due to this gravitational force, object is pulled towards earth. This is always attractive because it is not depend upon any charge and all, as both matter is neutral, whereas electromagnetic force deals due to charges of objects. Charges, as we know, are of two types, positive and negative. When positive forces, positive or negative forces, positive negative charges comes into existence, it becomes attractive force, and when positive or negative charges comes nearer, it becomes repulsive. Hence, electromagnetic force, when it is charges are there, charges can be at rest or charges are at rest or charges can be in motion. When charges are at rest, electric field come into existence, and due to this nature of the charge, it becomes either attractive or repulsive. When charges move, due to motion of the charges, magnetic field is created. Due to rest, electric field was created. Due to motion of the charge, magnetic field is created, and this magnetic field have effect on other moving charge. Again, this can be of attractive or repulsive nature. Other moving charge also creates magnetic field, and it becomes like two magnets, and the magnetic two, as we know, two magnets are, if it's kept, every magnet has its north pole, south pole, north pole, south pole. If other poles, opposite poles come into nearer, then it becomes attractive, and if same poles come nearer, then it will be of repulsive nature. Strong nuclear force is the force of attraction between these subnuclear particles, that is between proton and proton and proton and neutron. Weak nuclear force come into existence during certain nuclear decay. And It is the weaker than this strong nuclear force. Strong nuclear force is greater than electromagnetic force, and electromagnetic force is greater than gravitational force. Now the next one is energy, and this energy we will be studying what is different forms of energies and what is law of conservation of energy. As we know, to do any work we need energy, and this energy can be of heat, light, sound, etc. Electric. Law of conservation energy indicates conserve is any quantity is conserved if it remain unchanged or constant. Any quantity or physical quantity remain unchanged or constant, it is termed as conserved, and if the quantity is energy, then it is termed as conserved energy. Law of conservation energy says total energy remains constant. Only one form of energy can change to other and vice versa. Whereas total energy of the system during the process remains constant. This says laws of conservation of energy. Matter also can be termed as equivalent of energy with the formula E is equal to mc square. C is the velocity of light. Our next chapter is unit and measurement. Under this unit and measurement, we will be studying broadly two categories. One is unit and dimension, another one is errors in measurement. Under unit and dimension, we will have unit and dimension. Under unit, we will have unit and system of units. Unit will be of two types depending upon the quantity, physical quantity. As you know, physical quantity is, if it is the base quantity, the fundamental quantity, and other quantities are expression of fundamental quantity, those are derived quantities. We have only three fundamental quantities, that is mass, length and time. Using these three fundamental quantities, all other quantities existing in universe can be expressed. This unit of these fundamental quantities are termed as fundamental unit, whereas unit of derived quantities are termed as derived quantity. We know measurement. What is measurement? Measurement is comparison of an object with certain reference standard. reference standard is the the smallest existing one, and all other quantities are compared to this reference standard, and that becomes the numerical times numerical number that numerical number times of this base quantity. This base quantity is the our unit. Unit is the smallest possible object. With that we compare how much and what is the numerical number that times that big or small that our object is. The unit is the smallest reference standard with which other quantity that will be measured is compared. Then we say object is measured. Hence, measurement is the comparison of the object with certain reference standard. This reference standard is termed as unit. Unit of fundamental quantities are termed as fundamental unit, and unit of derived quantities are termed as derived quantities. Fundamental quantities are mass, length, and time. Whereas all other quantities other than this mass, length, and time, like force, acceleration, speed, etc., that will be termed as derived quantities. Under this system of units, we will have broadly three systems. One will be MKS, another is CGS, and is FPS. Fourth one will be the modification of MKS. It becomes SI, International System of Units, whereas MKS indicates mass, unit is kg, is meter, kg, and second. Under MKS, unit is meter, kg, MKS second. Under CGS system, unit becomes centimeter, gram, and second. Under FPS system, unit of length becomes foot, and pound, and second. Then SI system, it will be same as MKS, that is meter, kilogram, and second. Along with that, we will have other four fundamental quantities, that is electric current, unit is ampere, temperature, unit is Kelvin, and number of quantities, it is mole, and luminous intensity, unit is Candela. 7 fundamental quantities are considered in SI, and accordingly we have 7 units. This mass, length, line, electric currents, temperature, number of quantities, luminous intensity. The unit becomes meter, kilogram, second, ampere, Kelvin, mole, and candela. Under this error in measurement, right, dimension will be the expression of any physical quantity in terms of these fundamental quantities mLD with certain exponential of mLD. Under this error in measurement, we will be covering what is the error, significant figure, and errors in measurement, significant figure, and errors associated with measuring instruments. These errors in measurements. Yes, measurement can be of fixed or known nature or variable or unknown nature. Fixed or known errors, variable or unknown errors. On these errors, which is not known, that can be calculated with the help of absolute error, relative error, and percentage error. Under this error, we will have types and mathematical operation. Mathematical operation means when two or more different quantities are measured and their errors are calculated. If it is added or it is multiplied or subtracted, the final result we can find out. Under this significant figure, we will be studying what is significant figure, what is rules to find out significant figure, what is mathematical operation of significant figures, and rounding of significant figures. Under this measuring instrument, we will have terms associated with one major term is accuracy, another is precision, and least count. Types of measuring instruments we will be using are vernier caliper and screw gauge. Under this motion, we will have linear motion, rotational motion, gravitational motion. Along with, we will have knowledge or effect of force and energy. Force and energy. This force will have laws of motion, Under energy, we will be studying work, energy, and power. Under laws of motion, we will be studying different laws of motion, different types forces. Under this type forces, we will be studying friction, frictional force, spring force, other is lift, and connecting bodies. Another one we'll be studying is motion in curved path. The motion in curved path will be studying motion of car or motion of cycle. Under this motion of cycle, we will be studying bending of cyclists, this movement of car we will be studying on level road and banked road. These laws will have three laws. First law deals with inertia or mass. Second law deals with momentum and force. Third one deals with law of conservation of momentum. The friction will be studying laws of friction, types of friction. The types will be studying static friction and kinetic friction. The linear motion we had motion in straight line and motion in plane. The motion in straight line we had horizontal motion and vertical motion. Under horizontal motion we have motion on road, another one is under horizontal motion will have general motion and relative motion, relative velocity. General motion and relative velocity. Relative velocity can be motion of objects on road and river. Again, on River motion can be along the flow of river or perpendicular or across the river. Perpendicular to flow river. Along flow river. Now, under rotational motion, we will be studying what is center of mass and angular kinetic equation for angular motion, moment of inertia of different objects. Moment of inertia can be for rod, ring, disc, cylinder and sphere. Again, this ring can be this the cylinder can be of hollow cylinder or solids. Sphere again can be of hollow sphere and solid sphere. Now, under gravitational motion, we will be studying law of gravitation, accelerated due to gravity and satellite. Law of gravitation indicates the force, gravitational force, that is equal to or proportional to multiplication of both the masses and proportional to square of the distance between them multiplied by a constant g, gravitational constant. Where g is acceleration of the object due to Earth. That means when m1, let object m2, m1 is Earth, m2 is any object, then the force between them becomes mass of Earth and mass of object by r square. This is radius of Earth. Now it becomes mass and some acceleration with which object is pulled. This acceleration with which object is pulled due to this force. Then G becomes by r square. Other terms we will be studying. What is potential, what is potential energy, and another is gravitational intensity. U, P, and I. Under this satellite, we'll be studying Kepler laws, what will be the escape velocity, and what will be the orbital velocity of satellites. The last one will be variation of g, variation of g due to height, due to depths, and due to latitude. We'll have what is c and variation of